Hey Chemistry, Mrs. KJ here, going over part 3 of the Unit 1 Stoichiometry Lab. So, this question is like the game Jeopardy! You will be given the answer and you need to write the question. So the answer is, the chemicals were impure. We didn't mix very well. We didn't give the reaction enough time. So these are all basically excuses, right? Or reasons why something didn't happen. Alright, so why, what do you think? Why the chemical reaction didn't turn out perfect. And this is stuff in real life. Anytime you do a chemistry experiment, it's never perfect for these excuses or reasons. The chemicals were impure, so they weren't perfect because pure chemicals are crazy super expensive. Maybe we didn't mix it well enough. Maybe we didn't give the reaction enough time. So because of that, we're going to use this nice big red equation down here and find the percent yield. Again, in chemistry class, what does yield mean? It's like the arrow sign in a chemical reaction. It means makes or produces. You will never get a perfect yield or the perfect amount when doing a chemical reaction in a lab. Therefore, we need to see how close we are to perfect. We do this by finding the percent yield. You need to know how much was produced, which we call the actual yield because it's what actually happened, and how much should have been produced if everything was perfect. And we call that one the theoretical because it's a theory. In theory, we should have been perfect, should have been, but really we were not. We actually are not perfect. So percent yield can be in grams or moles, and we use this equation. To find the percent yield, or to see how good our reaction was, we take how much we actually got and divide it by how much we should have got, times it by 100 to make it into a percent. All right, if 1 FeNO3, parentheses 3, or 1 iron nitrate as a liquid, combines with 3 molecules of sodium hydroxide as a liquid, yields 1 molecule of iron hydroxide as a solid plus 3 moles or 3 molecules of sodium nitrate as a liquid. So this is what we start with. This is our recipe. Okay, think about if you are making the cars and the tires. Okay, so let's pause for a second. So every car needs how many tires? 4 tires, right? So 8 tires makes 2 cars. 12 tires makes 3 cars. 13 tires make, still only 3 cars, right? You have a leftover tire, but you can only make 3 cars. That's what it is in chemistry. Except instead of tires and cars, we need 1 of these, 3 of those. And that's going to make 1 of this and 3 of that. Okay? So that's why we balanced chemical equations to tell us the formula, the ratio, the recipe. So now it's saying, okay, so if I start with 1 mole of FeNO3, so if I start with 1 of these, remember mole is kind of like a dozen. A dozen means 12. A mole means 6.022 times 10 to the 23rd of anything. If it helps, think of it like molecules or copies. So I need 1 copy of this one and 3 copies of that one. Okay? How much of this should be produced? How many moles or how many molecules or how many copies of sodium nitrate will be produced? Well, the answer is 3. And I know that because of the 3 in front here. Now it says if 2.5 moles was actually produced, what would the percent yield be? Okay, so this is how much we should have gotten. This is how much we did get. So we're going to do the actual divided by the theoretical, and then times it by 100 to get our percent. So what are we going to put in our calculator? What we actually got was 2.5 divided by 3, because that's what we should have gotten according to our recipe, according to our balanced chemical equation. And then we're going to times it by 100. And what do we get? We get, oh, that could not have been right. Try again, Mrs. KJ. 2.5 Try it one more time. 2.5 divided by 3, and then times 100. There we go. 83.33%. So 83.33%. Now, if it was perfect, what percent would it have been? It would have been 100% if it was perfect. But it's not perfect, but 80% is pretty good. All right, let's do another one. So what about if I had 3 moles of FeNO3? So instead of 1, I have 3. I have 3 times as many. So if I change this one to a 3, what do you think this one changes to? Well, 3 times 3 is 9. What do you think that one has to change to? A 3. And what do you think that one changes to? Again, we tripled everything. So 3 times 3 is 9. So if we had 3 moles of iron nitrate and 9 moles of sodium hydroxide, then it would make blank moles of sodium nitrate. And if we tripled everything, it would make 9 moles. All right. Let's go ahead and do another example. If 1 mole, or 1 dozen, or 1 molecule, or 1 copy, it doesn't matter one of what, it's just the ratio. It's just the recipe, the proportions. So if 1 mole of iron sulfate as a liquid combines with 2 moles of sodium hydroxide as a liquid, it yields 1 mole of iron hydroxide as a solid plus 1 mole of sodium sulfate. All right, and let's say I started with 5 moles. Okay, so instead of this being a 1, it's a 5. It's 5 times as much. Instead of this being a 2, it's 5 times as much, so it's a 10. So how many moles of FeOH2? How many moles of this one would we make? If we had 5 times as much, it would be 5. So if we change this to a 5, this would be a 10, this one would be 5, this one would be 5. All right, so if I put 5 times as much chemical in, I should get 5 times as much reactant. Well, that makes sense. If you put 5 times as many eggs and flour and sugar and baking soda and chocolate chips into a bowl, you're going to make 5 times as many cookies. Same idea. But even though I made it 5 times as much, it's saying, look, it only made 1. Ooh, this was a pretty bad reaction. I was supposed to get 5 and I only got 1. Oh, ask for your money back. All right, what's the percent yield? So percent yield is actual divided by theoretical times 100. So what are we going to put in our calculator? What did we actually get? We actually got 1. What were we supposed to get? We were supposed to get 5, and then times it by 100. And what do you get? 20%. 20% yield. So not very good. Okay, that's the end of this lab. I hope it went well for you. Make sure you email me so that I know to put your grades in. Bye.